What is TEMS? So maybe we all know about IEEE, but if you can start with what is IEEE and then how TEMS is connected to it, and a little bit about TEMS.
Okay, so it's my pleasure. See, IEEE, the way I see it is, first of all, it's about advancing technology for humanity. So one of the key tagline for IEEE is focuses on humanity and technology. And that kind of melds beautifully into TEMS, really, because actually if you look at 40 plus societies in IEEE, we're the only ones that really dovetail really nicely into both all three aspects, advancing technology for humanity, that focus. So what is IEEE? I, in my mind, stands for inspire. And technology is all about inspiration. Advancing technology is all about inspiration. E, engage. So what we do through our chapters, technical activity committees and so on, is we engage people of all ages, of all experiences, whether they're in academia or industry or whatever, to get engaged. Through engagement, next is encourage. So by participating with us, networking with us, learning from us, we encourage them to grow personally and grow in their careers. And then the last E is empower. So now you become empowered to do more of what your life's dream is all about. So that's what IEEE for me is. Now, technology, engineering, and management. So let's take a look at a simple explanation of what technology is. And the way I see technology is anything, any device, hardware, software, whatever, that expands, enlarges, enhances, leverages, but sometimes replaces human capability. So if you take a look at GPS, it actually replaces human capability. It helps us, but I've seen taxi drivers who tell me that they've been driving taxi for 18 years, and when I was going from Long Island to New York, New Jersey, he took a wrong turn. And the reason he took a wrong turn is because he was relying on GPS. And
so it fails you sometimes.
It fails you sometimes. So that's a critical point. But technology is something that otherwise enlarges, leverages your capability. Engineering is a process of devising a device, a process through which you take an idea and you convert it into a product or a service, software or hardware. So that's the process. What's management then is, if you look at Oxford Dictionary, navigating through challenges. So technology and engineering management is all about taking an idea. So now we go to our tagline. Next slide, please. Here. So take a look at a human being making a marathon run. And so our tagline is technology and engineering management is to go from idea to product or service. And every technology, doesn't matter what it is, whether it's a robotic vacuum cleaner, or the new version of iPhone, or whatever it is a technology that starts from an idea and goes to some product or some service. So what are the 5 aspects of moving an idea to product or service? Well, the first one is a project. You're going from idea to product, and there are steps that you have to follow. So that is all got to do with the brain. We have to visualize, we have to conceive the idea, we have to conceive the process and move through the process. The second aspect of technology management is project management, because each one of these is a large project with some of the sub-projects. And what do the project management have to do? It deals with the who, what, where, and when. How do you do things? How do you manage? Looking at the critical path, the typical project management issues. Then we have the technology integration aspects of it, or technology management aspect. So if one is moving from a particular version of iPhone to another version, then you're going to change the Wi-Fi out chip. So you may go from a particular Wi-Fi standard N to AC to something else, or from 4G to 5G. So you have to make decisions of which technology you're going to roll out, which technology you're going to roll in, how it's going to be backward compatible, how it is going to be forward compatible, how it is going to be the adaptability, and those are all technology integration issues. And so one has to manage the issues related to that. Then you have the policy and compliance, the fifth area. And the fifth area, I want to go to fourth area, which is the human resources. Because technology management, most people think that technology is managed by managers. In reality, anyone who is dealing with any technology decision, even the people who are being managed are managing technology. So all of us are technology managers, because we're recommending to our bosses what technology we want to use. And so we have to be aware of what we're doing. And in doing that, we need to grow people from engineer to leader, because there is a growth in there as well. And that, in my mind, I compare it to the heart. Coming back to advancing technology for humanity. And the fifth, but very important aspect, and I've shown it near the feet, is because you have to be grounded. If you're not, when you take each step, if you're not grounded, you're going to slip on a banana peel, or fall into a pothole, or run against an obstacle. And that, to me, are the policy, the compliance, the ethics, and general human conduct. Now, let's take an example here. So, decades ago, Tylenol was coming in a bottle which was easy to break into. And somebody went and spiked a couple of bottles of Tylenol. Now, this is a case that's written up across the board for many years as a good example of management. So what the company did is call back all the products off the shelf. They owned up to the mistake that they had made.
Which they had not made.
Which they had not, it wasn't a mistake, but they didn't realize that somebody can easily spike into it. Looked at the technology, came up with a technology that protects against spiking, and released a new product in a very short time period. So that's an example of good technology management in terms of policy, compliance, ethics, legal issues, security, and so on. On the other hand, take a look at Boeing MAX 8, MAX 9, 737. The plane was designed to have two sensors and a warning light. But what the company did is offered the second sensor and the warning light as an option. So some companies like Air Canada, they went for everything. Another company, WestJet in Canada, they went for the second sensor but did not buy the warning light. And a third company in Canada, Transair, they only bought one sensor.
Perhaps it was not was good.
We don't know what the cost is, but the fact is that the plane cost about $125 million.
This can't be that much.
a second sensor which is already there, and the location for the second sensor is already designed. The warning light is there and the wiring is there. They're not going to start wiring. So it was a matter of only mounting the second sensor, paying for it, and paying for the warning light. That wasn't done. And as a result, what we find that hundreds of 737s are sitting on tarmacs. And the interesting thing is that these planes cannot sit forever on the tarmac. So the airlines have to fly the plane across. So all these airlines in Canada are flying this plane across Canada every few weeks or every few months, completely empty, with a full crew.
Just to keep it alive.
Just to keep it alive. So imagine the cost the company is paying and the customers are paying. And that, to me, is the fifth area. Now, that is what I see technology and engineering management. And this is one field that within IEEE is absolutely completely unique as compared to any other society in actually.
I think you have given a very good overview of where it starts and where it ends, how it blends into what we do on a daily basis. So one last question is, how does TEMS relate to, say, students and academia, faculty on one side and professionals on the other side? How can they connect to what you just said?
Actually, I want to tell you the approach. I used to be an adjunct professor at Simon Fraser University, and I worked very closely for almost 20 years with one of the professors there, senior professors. And one of the things we did together, in addition to research, is every PhD, postdoctoral, master student he had, I was a co-supervisor. And it was a requirement that every thesis had to have, obviously, the theoretical research to it, but a practical application. So the job of the professor was to supervise the theoretical aspect, the research aspect, and my role was to provide an actual industrial application where the student had to develop the theory and the practice and implement it in a company to show the benefits of that. So this kind of thing is useful. It starts from the students. But as you grow out of university, you start looking at the research and applications and so on. Then as you move into the industry or into academia, it is important for you to understand where technology is needed, how it should be pervaded, and how it should be adapted and integrated into the normal business cycle, regardless of whether it is designing a new runway for an airport, or new grain or coal terminal, or new oil and gas pipeline, or new distributed hydrogen energy system for fuel cells. Doesn't matter what it is, everywhere the technology is advancing rapidly, and it is applicable to everybody from young professional to middle managers to the chief executive officers who need to understand. And the reason I say chief executive officer is going back to the Boeing example. Those decisions were made at a very high level. And that is where the responsibility lies. That's why they were called by the Congress for a hearing.
Yeah, I think the key aspect is the decision making, and I think managing is critical to achieve success, irrespective of how good your team or how good your idea is. So I think it's beneficial to all the categories of professionals or would-be professionals in the academia. So I think it's a fantastic way for us as TEMS to work with researchers and professionals and help the humanity to advance with the help of
and the consultants,
and
because the industry are focused on adapting technology, using technology. Consultants are the purveyors of technology, and they
Implement
help the
decision.
industry adopt and integrate existing technology, and the researchers are responsible for identifying the opportunity for new technology so that it can be purveyed by the consultant to the industry. So there is a pipeline going from the research, from idea to the product. And this idea to product applies also to academic consulting and industry.
Wonderful. So I think as TEMS we have a lot of opportunities and a lot of work to do.
Lot of work.
Thank you so much for enlightening us.
My pleasure.
Thank you.